Conditional statements are also known as if-then statements, and they consist of two parts, P and Q. And the hypothesis is designated by the P, and we usually underline it once, and the conclusion is designated by the Q. So often you'll see this symbology, and it just means if P happens, then Q is going to happen. So an example would be, if there is a blizzard, then there is no school. There is a blizzard is the hypothesis. There is no school is the conclusion. And we can denote these by underlining the hypothesis once and double underlining the conclusion. So the converse is when we reverse the order. We're going to say if Q happens, then P does. So take a guess as to how we might say this original sentence, if there is a blizzard, then there is no school, in its converse order. We'd say if there is no school, then there is a blizzard. Now, for right now, do not worry about whether things are true or not. We're going to get to that in a moment. So, how do we tell if a statement is true or false? Well, a statement is true if it's always true. If there is one time that something isn't true, then it is false. So it's false if we have at least one example where it's not true. And this example, as you know, is called a counter example. So let's think of some counterexamples to the converse, because it is true. If there is an actual blizzard, not a snowstorm, then there is no school. So if there's no school, then there is a blizzard. I want you guys to come up with some counterexamples to this statement. So you're trying to find times when there is no school, but there was something other than a blizzard that happened. And we'll check those out in class. And now for biconditional statements. As you know, bi means two, so there's going to be something going on in two different directions here. If a conditional statement and its converse are both true, then we say that it is a biconditional statement. So in this case, it says P if and only if Q happens. And a way that you can abbreviate that, just so you know, is there's a double if. That means if and only if. So let's see if we can organize these. I want you to underline the hypothesis once and the conclusion twice. And let's just see if each of these sentences, when taken on their own, are true. Now remember, don't underline the if or the then. They're not actually part of the hypothesis or the conclusion. If it's a right angle, then its measure is 90 degrees. That's totally true. And if an angle's measure is 90, then it is a right angle. That is also true. So since it's true in both directions, we'll say it's biconditional, and we want to write it that way. So the easiest way to do it is take this first sentence and just write the P part as it said. So instead of saying it is a right angle, we want to know what it is. So I would say an angle is a right angle, and then we put the if and only if, and then you say the second part of the sentence. Its measure, it does not have an apostrophe. Do not put that in there. Its measure is 90 degrees. And that's written in its biconditional form. So you're going to try a few of these on the back. You're going to come up with two sentences. They don't have to be about math, kind of like the blizzard sentence. If it is raining, then the ground will get wet. Like any if-then statement you want to come up with, write the original conditional, then write its converse, and then determine, is it biconditional or not. If it isn't true in both directions, I want you to give a counterexample to either the first sentence or the second. See you in class.